Hi, you are taking notes on topic C, lesson 22C. This is from Engage New York for Algebra 2. And if you're following along, you have some notes that look kind of like this. And there are multiple parts in this lesson. This is the third part, or part C. And today we're going to talk about dividing rational expressions. The last two videos were on multiplying rational expressions, and now we're going to talk about dividing. And to divide fractions, rational numbers, you learned some kind of algorithm where it said to multiply by the reciprocal. So to divide two rational expressions, we flip and multiply and simplify. And if you're wondering where I got this definition of the process, it's from Khan Academy. So this means that we have to find the reciprocal of the divisor. That's what we flip, the reciprocal, and then multiply this by the dividend, or our first fraction. So let's just take examples that we know. We know fractions well. So let's do, for example, 3/2. Let's call this example 1. 3/4 divided by 1/2. And what we need to do is we need to take the second term. The second term gets the reciprocal. So we have 3/4, and then we change the division to multiplication if we take the reciprocal of the second of the divisor. So now we have 3/2, which turns out to be 6/4. And if you are trying to simplify this, one way you can do this is imagine factoring out a 2, and you have a 3 left over, and imagine factoring out a 2, and you have a 4 left over. So you end up back with, 3/2. Okay, so this is one way to do this. And if we had, for example, let's do an example with a rational expression instead of just rational numbers. And let's do this example 2. 3/4x divided by 1/2x. So it's similar. You have rational numbers, and now we have rational expressions here. So we are going to do the same thing, where we're going to take our dividend. That does not change. We're changing the division to multiplication, and we're going to multiply it by the reciprocal of the divisor. So now instead of 1/2x, we're going to have 2x/1, which leads us to, I'm still going to multiply this across, just like in our previous videos, we've just multiplied across, 3/2x/4x. Now what I'm going to do is I'm going to start to simplify, and the way I'm going to simplify is I'm going to take out all the factors that I think can cancel into 1, and I'm going to write them first. So I'm going to have 2x. I'm going to leave the 3 on the right side. If I take a 2x out of 4x, I have 2 left over. And indeed, 2x/2x can equal to 1, simplify, and I'm left with 3/2. The only thing we have to do first is we need to talk about how to find undefined values in the denominator. So what I didn't do in this example was call out the values that would make the rational expression undefined in certain ways. So in the next part of your notes, which you are titling Finding Undefined Values in the Denominator, which got separated from here, let's read a little bit of a text that talks more about undefined values. So an expression that results from the multiplication or division of two rational expressions is undefined for any variable value that makes at least one of the original rational expressions undefined. That means that if we have an example and there is a number or a value that makes it undefined in any way, then it's going to be undefined for the entire problem. So let's say, for example, we have x minus 1/3x divided by x plus 2/x minus 4. So an expression that results from the multiplication and division of two rational expressions, that's what we have here, is undefined for any variable value that makes at least one of the rational expressions undefined. So let's just look at these separately. What value of x would make this rational expression undefined? Well, you would say x cannot equal 0, because that would make it undefined. What about this expression? What value of x would make this expression undefined? And you would say, well, x cannot equal to 4, because then the denominator would be 0, and then we wouldn't be able to divide an undefined value. So now what we do here is once we go through our problem and we finish, we take our result, we take our quotient, and then we also have to evaluate the quotient and ask ourselves what value would make the quotient undefined, and then we have to exclude that value as well. So at this point, what we can do is we're going to divide. So we have, I'm just going to go through this example and then we're going to break it down step by step later. So we have x minus 1 over 3x times x minus 4 over x plus 2. So the same thing I did in the previous example is I'm multiplying by the reciprocal. And now what I'm going to do is I'm going to write out all my factors together. I'm multiplying across. I have 3x and I have x plus 2. And I have to check what values would now make this expression undefined. We already have that x cannot equal 0. And now we have to look at this factor and we have to say, oh yeah, x also cannot equal to negative 2, because that would make this factor 0 and the whole expression be undefined. So the whole time I was doing this, I started by identifying which values make it undefined, and then I ended my problem by identifying values that would make the expression undefined. Let's keep practicing. If you have questions or you need to put some caution marks, go ahead and do so now. Otherwise, let's move on to our next example. And we're going to find the quotient. That means we need to divide, and we need to reduce to lowest terms. So let's say quotient means divide. Okay, so we have 16 over 3x divided by x minus 2 over 2x. So we are going to follow very similar steps, but we need to identify values that make expression undefined. And then we are going to factor, if there are any factors that we can factor out, greatest common factor, or if there's a trinomial, GCF, or a trinomial, you're also going to do that factoring. And then you're going to divide, but you're going to divide by multiplying by the reciprocal. Multiplying by the reciprocal. And then you have to simplify. And then finally, I'm going to put a 1 here because you have to go back to find values that make the expression undefined. Okay, let's see if I can take this and shrink it down a little bit. Okay, so let's go through our steps. Values that make the expression undefined. Already, I know that x cannot be 0, because if I put a 0 in here or put a 0 in here, that would make my expression undefined, so I already have to exclude 0. So now what I'm going to do is I'm going to factor. Looks like it's pretty factored already. I think it's okay, and now I'm going to divide. So I have 16 over 3x. I'm going to change this to a multiplication if I promise to take the reciprocal of the divisor. Now I get to multiply across. So I have 16 times 2x over 3x times x minus 2. And I'm again going to line up my factors that I want to cancel. And this is just good practice that keeps my work organized. So now I can easily go like this and then write 16 times 2, which is 32, over 3 x minus 2. And now I have to evaluate again. I simplified, but then I also have to make sure what are values that would make this expression undefined, and I would have to add to my list of x's that you cannot include, and I can now not include x is equal to 2. Okay? Okay, for example 4, it's going to be the same directions, so let's try this again. I think I can move this guy with me. Let's go. Stop. Okay. He's coming with. Huh. Okay. Values that make the expression undefined first. So now let's write values that'll make the expression undefined. X cannot equal -4, because if we put -4 in here, it's going to make both of these expressions undefined, and we can't divide by something that's undefined. Okay, now let's factor. I'm going to draw a fraction bar. I'm going to write x minus 6 and x plus 1. I'm using mental math to factor this trinomial into two binomials. And then I have x plus 4 in the denominator. I'm going to multiply it by the reciprocal of my divisor, which is now going to be x plus 4 over x minus 3. Okay, so at this point, draw a big bar, and I'm going to write all my factors together, just like we've been practicing with multiplying. I have x minus 6, x plus 1, x plus 4. Okay, what can I line up in my denominator? I have an x plus 4, and then I'll just write my x minus 3 over here, because this allows me to cancel out this factor, and I'm left with x minus 6, x plus 1, and x minus 3. So what else? Now I reevaluate this again, and I think what values of x would make my expression undefined, so x cannot equal 3. Okay. Let's move on to our last example. It is a great example. It looks kind of weird, but I want you to know that a fraction within a fraction is called, and here's where your vocabulary words come in. If you're writing that on one side of your paper, your main idea is vocabulary words. However your system is to keep track of vocabulary words, this is called a complex fraction. Complex fraction. Okay, so let's take a look at this complex fraction. And we're actually just going to rewrite it first of all. We're going to do x minus 1 over 3. This big division sign, this big bar, is just, you can just replace it with a division sign. So now you have x squared minus 1 over 12. Okay, at this point, our rules have not changed. Let's go get our rules. Come with us. Okay. Oh no, we took a 4. That's okay. Okay, now we need to identify values that would make this expression undefined. So if I'm looking at this, I have a 3 and a 12, which means it's always going to be defined. Great, I don't have to exclude any x values. Then I'm going to factor, so I have x minus 1 over 3 divided by, I'm going to factor x minus 1, x plus 1. Again, it is our trusty friend, difference of squares. And now I'm going to multiply by the reciprocal. So I have x minus 1 over 3 times, I'm going to write my 12 in the numerator, x minus 1, x plus 1. Well, and now I'm just going to multiply across. So I have x minus 1 times 12 over 3, x minus 1, x plus 1. Okay, what I'm going to do at this point is I'm going to rewrite my factors so that I'm going to write all my numbers first, and then I'm going to write my factors, and I'm going to try my best to line up any factors that cancel out. X minus 1, x plus 1. Oh, that's very handy. This cancels out to 1, and then 12 over 3, I'll write this out, 3, 4, 3, and then x plus 1. All right, so this also cancels out. So I'm left with 3 times 4 is 12. That's where I got that 3 and 4. Okay, 4 over x plus 1. And then I have to think to myself, what value can x not be? This is my quotient, and I'm looking for values of x that x cannot be to make it undefined. And I say x cannot equal to -1. So I have to add, oh yeah, I didn't have any in the beginning. So now I have to say that x cannot equal to -1 to make this example complete. Okay, at this point, here you are. You're writing your summary. Bullet point your main ideas, add any questions, annotate what you know and then what you are still struggling with. Bring your questions into class, check if you have a problem set, and I will see you tomorrow. Bye.